Hey guys, welcome to the level 1 chance and data paper from 2022. Yep, you're right, I am doing statistics. Well, we all got to do things that we're uncomfortable with at some point. Anyway, so if you're joining us for the first time, the way this video works is that I go through each question, let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question. Try it out by yourself and then unpause the video just to see how I go about answering the questions. Now, also with this particular chance and data paper is that anything that's going to be written like massive kind of essays, I'm going to just write them down as bullet points and just kind of do the explaining more than the writing of it in the video. So without further ado, let's get started. Now, since it's the first time I'm actually doing this paper, I thought it might be a good place to actually go read the assessment report. And seems like, where was it? Geometric reasoning, chance and data. Here we go, chance and data. I think this is the part that I was really interested in, that essay style responses are not required. Bullet point answers are acceptable and may help candidate ensure they have answered all aspects of the question. So from my understanding for that is that we don't need to write really long essays. Yay. And bullet points, even better. Alright, question 1a. So what we've got here with question 1a is using what's the date when the daily recorded was the coolest. Oh, so coolest, we're looking for the coolest one for which date? What was the date? Oh, it doesn't actually mention which year, so I can kind of see that it's this point right here. And looking at it, and you can kind of see that it's between 13 and 14. So how do I know what's the right answer? And I guess if you kind of have a look at it, it actually says that they're doing the maximum first for the day and then the minimum after that. So if we look at like on the first of the month, so notice how that's the maximum for the first and then this is the minimum for the first. So if this is the case, we can see that the maximum for the 13th is there and the minimum for 13th is there. So our answer for question 1a would simply be 13th November, and it's the blue line, and because it's the blue line it is going to be 2009. Basically that is worth an achieved grade, and we move on to the next question. Alright, question 1a part 2. The question is asking what's the probability that there was a minimum temperature lower than 10 degrees on a randomly selected, so this is 2019 data. So remember that the 2019 data is actually the yellow line here, and we're looking for something that is going to be less than 10 degrees. So now 10 degrees line is right here, and as you can see there is really only one point when it's actually less than 10 degrees, when the minimum is less than 10 degrees. So what we're going to say is probability of less than 10 degrees. So we can just write it like this. Less than 10 degrees is going to be 1 out of 30. Now, I know that looking at the answer schedule, they were saying that you can leave it as a fraction. But if you do want to leave it in a decimal, you're going to have to put that as 4 decimal places here. So that's what I see in the answer schedule. So I would probably stick with that. But I might need to look up further just to double check on the number of decimal places required for probability. Normally I think it is 4 decimal places from memory, but although don't blame this memory because this memory is from like almost 14 years ago. So anyway, let's go on to the next question. So as mentioned before guys, for this question, if you'd like to see the full answers, I'd actually go check out the answer schedule there. I mean, they've actually written down full statements, but what I'm going to do is I'm going to run down some bullet points here and try and connect it to the schedule as well. So I kind of had to write this as a bullet point here. The first kind of bullet point that you can kind of see here is that when you look at the daily temperature for 2019, the yellow line is actually more varied than the blue line. Now, if you look at the blue spikes, they're kind of going up in a fairly kind of like upward trend there, the blue one, right? But if you look at the yellow one, actually I might actually do this in a highlighter. So the blue one is kind of going like that. The yellow one is more like doing kind of like a, it's going up and then it's dipping down and then it's going up again. So that is going to be one of the first I guess features that I could talk about in this graph. So the next point that we can have it talking about is the average temperature for 2019 is actually higher than 2009, and that's partially because if you look at the temperatures themselves, right, the yellow ones, there's a lot more yellow ones that are actually higher here compared to the blue ones, and so that's one of the other bullet points, other feature that we can actually talk about, where the temperature is actually higher for 2019, a large proportion anyway, compared to 2009. The third feature, which kind of follows on from the second one, is that we can kind of see there's quite a lot of yellows that are popping up, but when we look at there's only like two kind of areas where the blue maximum temperature, which is the 2009 maximum temperature, is actually higher than 2019 max temperature. So that could be a third feature. All right, and as for bullet point number 4, what we're looking at is the fluctuation. We're actually looking at what's happening with the max and minimum temperatures. Now, if you look at it, if I was to have a look at this little kind of blue maximum here, right? And I guess what you guys can do is look at the difference between them. And I think there's only like one obvious spot where the temperature is about 10 degrees, which is on the 12th. Because if you look at it, that's 20 and the minimum's at 10. But everything else is actually less than 10 degrees fluctuation. Now, as for the yellow one, I might have to use a different color here, but so I'm gonna try and get I think the yellow one has actually got a lot more fluctuations, like the gaps are like there are lots more points where it's actually more than 10 degrees, especially at the beginning of the month. You can see like these kind of like this area here where there's some huge kind of spikes there. So that's another feature that you can actually talk about. And now we'll just have a look at the last one here. And the last point is when we have a look at 2 days in 2019 where the max didn't peak, and there's not much difference between the minimum from the previous day and the max from the next day. What do I mean by that? Let's go have a look at this right here. So the points I'm looking at is here and here, which is on the 11th and 19th. We probably should have said that the 11th and 19th in our explanation, because everywhere else, if you look at it, the spike should have actually happened here before it came down. But then I don't know, something's happened there that that the difference between the low and the max for the next day, you should have had a little kind of like a spike that's happened like this. And again, in this situation, it didn't happen. So it's just something else to notice and write about. But let me just cross that out. And I think we just want to make sure that we actually put that 2 days in 2019. We want to actually put in a good idea to actually write that it's 11th and 19th, because again, you've got to kind of be very specific with these, giving all the right information if you want the full grades. By the looks of it, it looks like we've given 5 here. They're looking for 3 features with clear justification, so giving that reasons, not just writing it and just going without any justification. So you can't just be like, oh, 2 days in 2019 didn't peak. You've got to actually kind of explain what's happening and then give them some data to back it up as well, or justify. That's the word I'm looking for. See, I could tell this is the first time I'm doing this. But anyway, guys, look, that's an excellence question. If it looks like one sensible feature is like an achieved, 2 sensible features is a merit, 3 with a bit of like, hang on, let me just show you guys this. So right here it says like 3 sensible features identified with an attempt to justify gets you a T1. So even putting down 3 features, that's pretty, it's not bad for a T1, to be honest. And then kind of putting that justification gets you a T2. Right, let's go to the next question. Alright, so what we've got here, 1 day in November and 1 day in December in 2019 is randomly selected, blah blah blah. Find the probability that both days are more than 20 degrees. Okay, so if we have a look at it, more than 20 degrees in November is actually 3 out of 30. So that's going to be probably, I'm just going to write it down first. So probability of both days, so both with more than 20 degrees, so greater than 20 degrees. Now, okay, right. You could use the symbol there, but you could also write it down as well if you are much more comfortable writing it down. So first off, I'm looking at November, which is actually 3 out of 30. That is for selecting 1 day in November where it's more than 20 degrees. Right now it is, and because of this and, we've got to have a multiplication symbol, and then we've got December 2019 as well. So for December 2019 we're looking for how many days that were more than 20 degrees. That's going to be 11 out of 31. So hopefully you can see where that multiplication symbol came from. We can then do this as 11 over 310. And of course you can actually put this in the calculator and write it as a decimal. So 11 divided by 310, 0.0355. Yeah, well, the answer schedule actually has only 3 decimal places. I wonder why. I need to actually look that up, guys. I would have put it as 0.0355. But again, I would also leave probabilities in fractions because I'm a lot more comfortable with that. So grades wise, the full grade is going to get you a merit and 1 probability correctly found. Oh wow, okay, so this is basically, you could get an achieved for either this or this. Yeah, so that's basically it for this question. Let's go to the next one. Alright, so for part 2 of this question, we've got some claim that the average temperature in 2022 and 2022 December will be similar. It's quite fascinating. Compare, I mean, based on the data from 2019. Alright. Now, the first thing is, I mean, it's, you know, we can't actually say that this is actually valid, right? This is not valid. I'm going to write bullet points first, and then I'll talk you guys through. So the first point is, you know, as I said, like, it's not valid because, I mean, you know, 1 year could be completely different to other years. The number of hot days that you get in a year is also, it's different from every year. I mean, if you guys think back to the start of 2022, you know, we were supposed to have, what, an amazing summer, and we didn't have an amazing summer. And what we ended up happening was one of the worst. You know, we had a cyclone, we had like so much rain, it was ridiculous. Right? And if someone actually comes and says, okay, now this is what January 2023 looked like, doesn't mean we can use that data to say that in January 2025 we're going to expect that much rain, right? It doesn't actually make sense. So you can't really make that claim. So that's the first one. Now the second point, of course, is that, you know, I mean, if you think about it, there's only 61 days in November and December, and the probability can actually change just based on a few extra hot days. Now, I'm going to go back to the January 2023, you know, the rainfall. Like, you know, just because we had like a little bit of rain, right? No, I'm not saying this right. Hang on, let me rephrase that. Like if we go back to just like, I mean, I'm going to go back to November and December for the 61 days, right? Like if you get like a couple of extra hot days, let's say we get like right now it says 3 out of 30 that's more than 20 degrees. Now let's say you get like, I don't know, 2 more days that happens, suddenly it just went from 3 out of 30 to 5 out of 30, and so the probability will actually will change based on that. So once again, we can't actually claim that those temperatures from 2019 will be similar in 2022. So the other thing also is that like we don't really know what type of average they used, and if the mean was actually used, then you're going to get some really distorted results if you have like extreme situations that happen. And again, and I know I'm going back to the January 2023 example because there was a lot of rain. And we know that like the average rainfall in January for this year in 2023 was actually a lot higher compared to other Januaries, and that's because we did have an extreme weather event and average rainfall did increase at that point. And of course the last one, we know that temperatures are rising globally, and then forecasting from 2019 to 2022 it actually can be risky. Because we've had some extreme weather events, and it's kind of played a part in temperatures around the globe. So I'm sure this is something that we need to consider, especially in Auckland as well. Cool, guys. I know I kind of like rushed through with the word, the written kind of part of this. So please, if I went through it too fast, I will see if I can put the link of the answer schedule. Go have a read through it, so you get a bit more idea of it. But this is to the best of my ability here. Now grades wise, you kind of need, we've talked about 4 bullet points here. One reason is going to get you an achieved. So one kind of valid reason with justification is going to get you an achieved. 2 valid reasons with justification will get you a merit. Cool, that's basically question 1. We now go to question 2. All right, so question 2 here. What do we have? Got a bunch of red lines. The red lines are, what are the red lines? Red lines mean that the average temperature was above the long-term average. That's what the red one means. The blue one is the average temperature below the long-term average. And it's nice they actually give you an example. For example, in 1992, the average temperature was 1 degrees below the long-term average temperature. So if we look at 1992, that's this one right here, and that is 1 degrees below the long-term average. Okay, seems to make sense, but let's go and look at the first question. The first question says, what is it? In which 10-year period the average temperatures were all below the long-term average? That's basically between here and here, because that's pretty much all the blue lines in that decade is, I shouldn't have used the red for that. That's actually below the baseline average. So our answer for question A, part 1, is going to be between 1940 to 1950. And a correct answer is going to get you an achieved for this. And we go to the second part of this question. Now guys, look, I know this might be a bit tiny here, but it's just trying to fit all of this into the screen has been a bit of a mission, but hopefully you can actually download the paper and just kind of have it in another screen open somewhere so that you can have a look through the paper in much more detail than trying to watch this on a small screen. So the question's actually asking us to identify features from the graph that can be used to support this claim. Now, what is the claim? The claim is that in recent years, the concern is that temperatures in New Zealand are rising. Okay, so let's kind of work through that at the moment. Now the first thing we're having a look at is the frequency of positive anomalies, right? Like that's basically like the number of times that it's actually gone up in the last kind of recent years. And if you look at it, that's the red line. All those red lines are basically saying that it's actually above the baseline average temperature. So we're going to write that down first. So as mentioned, guys, there's a much higher proportion of recent years than annual average temperature anomalies were above the baseline. So that's basically looking at this part of the red spikes there. There's a lot more. All right, and our second reason is going to be, second bullet point is that if we look at before 1970, the temperatures only jumped above zero occasionally, so that's around here, right? Let me just put that out again. So you can see that they only kind of randomly went up on the odd occasion, but when you look at it recently, they are actually rarely below zero, which means that recently they're actually way more higher. So it's just kind of picking those differences out. So before 1970, they were only above zero occasionally. After, like more recently, they're actually below zero only on the odd occasion. So it's kind of saying rarely. And the third bullet point is actually looking at the amplitude of those anomalies, right? So that is, if you look at it, in the recent years, a lot of anomalies were above 0.5 and close to 1. So that's basically here, there's a lot more that are above 0.5. But if you look in the past, they hardly went they hardly went past 0.5. But recently, there's been like a massive spike where the amplitude, that's like the distance between the max and the min, it's actually a lot higher in the recent ones compared to the past. Right, so all three of these things, guys, I think this is one of those questions where, you know, one valid feature gets you, with justification, gets you an achieved. So it doesn't matter whichever one it is. So 1 gets you an achieved, 2 gets you a merit, and 3 bullet points here will get you an excellence. Again, like I'd say this to you guys, you know, feel free to go and have a look at the answer schedule, just in case if I feel like I haven't explained it enough or I've missed something there. It's worth having a look through those answer schedules. All right, let's go to the next question. All right, so question B1 here, what are we looking for? We're looking for the state the average temperature for Auckland in 2019. So what we've got here is, first off, the highest average for Wellington was recorded in 2019, which is this point right there. Oh, I actually have a ruler. There you go. So based on that, average temperature for Auckland, I can say, is going to be 16.1 degrees. Correct temperature value stated is worth achieved. And then we go to B part 2. Just going to rub out this. I have a feeling I'm going to need this part, so I'm going to rub it out. So have a read through that question first. If 2 years are randomly chosen, what's the probability that the average in both years are above 16 degrees? Alright guys, so I guess the first thing we need to figure out is, out of those 54 years, how many years are actually above 16 degrees first? So for Auckland, well, I guess it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 times out of those 54 years where the temperature has been above 16 degrees. So that is 9 out of 54. Now the question though is asking, if 2 years are randomly chosen, what's the probability that they're both years are above 16 degrees? Now the first one is that it's going to be 9 out of 54. The best way to kind of do this is, let me just show you guys in a tree diagram, but I'm just going to show you guys the first part of the tree diagram. All right, so let's have a look at it like this. So this is for above 16 degrees, we're going to get 9 out of 54, and then 54 take away 9, whatever that is, 45 out of 54 is going to be less than 16, right? Then we're going to get above 16 again, but this time we've only got 53 years and we've only got 8 years left over. So for both years above 16 degrees is we're looking at these two branches, and remember that when we go along the branches we actually have to multiply the probabilities. So we're going to get 9 over 54 times 8 over 53, whatever that is. 9 over 54 times 8 over 53 gives me that, but I prefer it in fractions. So in fraction my answer is going to be 4 over 159, and in decimals it is asking you to give the answer with 4 decimal places. So therefore I'm going to go 0.0252. If you're wondering where I got the 4 decimal places, it is from there, and therefore I will actually leave the answer in 4 decimal places. Now grades wise, this final grade is worth a merit, and you can get an achieved for just doing the 9 out of 54 there. That's worth an achieved right there. All right, let's go to the next question. Alright guys, so part 3 of this question, describe and interpret at least 2 different features. I guess, again, I'm going to kind of bullet point this, so just bear with me. So the first part is positive relationship, and you can kind of see that here, because as the temperature in Auckland increases, temperature in Wellington tend to increase as well. So that's your positive relationship feature. Is that a feature? Yeah, that's a feature. And then the second one that we're going to is the relationship is actually a linear one, because I mean you can kind of see like a straight line just kind of going through that. What else can we say? We can actually say relationship is moderate. And the reason we can say this is because points actually do not form a closed band throughout the graph. They kind of spread out a little bit, but not kind of, I wouldn't, you know, that's why you kind of call it moderate. So the next thing is looking at interesting values. So the first one we're going to look at is the 16.6, 13.8, which is right there. I mean, it's a little bit odd that Auckland has it's one of its highest temperatures on average, but Wellington seemed to have kind of dropped a little bit. So it's a bit of a strange one. And the other one that's even more kind of awkward is the 14.9 and 11.8 in Wellington, which is this point right here. So again guys, looking at the answer schedule, you have got 3 features clearly identified with some interpretation is going to get you excellence. So it seems like a bit of a pattern here that I'm looking at. 2 features clearly is merit, 1 is achieved. By the way, this is one of those, like a really weird question, because I'll show you guys the schedule, because it looks like you can actually get this excellence from 3 or 4. So I'm not sure what that is, but we'll have to follow up with the next question to try and figure out how that actually works out. But as for the features of the bivariate graph, those are some of the key points that we've kind of covered here, but let's have a look at the next part of the question. So how useful is this graph to predict the weather in Wellington and Auckland? Okay. Alright guys, I think this one, I mean, you can actually have it as useful or not useful depending on your supporting evidence. Alright, and I think the best one is probably just to have a look at the schedule here, just to get a gauge of this. So as you can see, the first part they say is that useful on the predictions won't be that useful because the relationships seems to be moderate. But then you can also comment that the predictions will be useful because the relationship is moderate. So it's a bit of a catch-22. It's how you decide to answer the question as well. So as you can see, there's like 3 bullet points here that's talking about useful. So it is useful because graph provides a lot of data from lots of different years. And we can also say it's useful because we can see that the Wellington temperatures generally tend to be a few degrees cooler than Auckland, and that's kind of shown in the graph here. So if I can go back to the graph, you can see that the graph, like it's when Auckland's at 16 degrees, Wellington's about 14 degrees. So it's generally cooler. Now you can get a little bit how do I say it? You can get a bit technical with this by finding the line of best fit and stuff like that, but we're not going to go down that pathway. Now, as for if you decide to go that it's actually not useful, then you can say that it's not useful because, again, like have a look at the difference. There are some sections of the graphs with not enough data to see what the relationship should be. Not useful particularly at the higher or lower temperatures. So if I go back to here, there's at the higher end of the temperatures, like here, there's only like 2 or 3 points, and even with the lower one, you've only got like only like 3 points between that 14.4 to 14.6. And I think this is the last part here. Not useful because data provided is temperature. Temperature is not it's not the only indicator for weather. So you kind of need wind strength, and rainfall is also needed. So if you think about it like that, because especially with Wellington, with the Wellington weather, so especially with the Wellington wind, it has an impact on the temperature, right? But again, that's what they're saying, that this is not the only indicator for the weather. And as we looked at the schedule before, this is kind of connected to the previous question. So like if you look at it, it says you can get excellence for this question if you get 3 of those features correctly, and it kind of says it can be from 3 or 4. So I guess you can actually get an E7 just by answering 3 features there. Now again, guys, as I said to you before, this is my first time actually doing this paper, so if there is anything that I've missed out or made mistakes on, feel free to drop it in the comments. And it's a learning process, and happy to learn here and kind of work through this at the same time. Alright, so I think that's question 2 done. We now go to question 3. Alright, so question 3A part 1, what we're looking at is calculate the interquartile range. So if we're looking at the interquartile range, that is basically upper quartile. We're looking for after 1980, which is this. So we're going to go upper quartile minus the lower quartile to get our interquartile range. So IQR is upper quartile minus lower quartile. So 11.69 take away 11.05, which is going to give us 0.64 degrees. Now it does say comment on how this value could be used in the analysis. This is just the amount. I've got to pause to write this out. Give me a sec. Gotta mention the amount of variation of the middle 50% of the temperature in Dunedin for the years after 1980. Alright, basically IQR is just the middle 50%, and that's pretty much it. Grades wise, that's going to be worth and achieved, and we move to the next part. Let me guess, compare the distributions. Okay, so we just pretty much asked to give the key features of off the box and whisker graph there, so we'll work through. So the first thing we're going to be talking about is the center itself, and it's nice that they actually give you all of these things in the paper, so you don't actually have to remember them. So I guess for the center, we're looking at the median here, and we just kind of have to write it down. So the median temperatures are very similar, because one being 11.33 for after 1980, and then the other one being 11.28 for before 1980. So the next one we're going to be looking at is the shift. The shift, I mean, if you look at the shift, there's not really much here, because the middle 50% is overlapping the middle 50% of the the other one there. So I'm just going to write that down. So the shift is that the middle 50% box overlaps each other completely, because if you look at it, it's the wrong color. So that's that thing right there. I mean, it's literally overlapping each other. So we can't really comment on much about the shift. All right, so next is we're looking at shape. So I guess with looking at the shape, and again, this could come down to your perspectives, because I guess in my one I kind of see like a kind of like a symmetrical shape, while some others might actually say that after 1980 skewed slightly to the left, because there's like a skew here like this after 1980. Or you could actually say before 1980 had a little bit of a skew to the right. And again, it just depends on how you see it. In the answer schedule, they actually accept both answers, where they accept symmetrical or the other version, which is the skew in the after 1980 part and the before 1980 part as well. All right, next up we're looking at the spread. Okay, as for the spread, you can kind of see that the temperature after 1980 is actually more spread out compared to the before 1980. But then we are looking at the interquartile range, and even if you look at the interquartile range, that box is actually much bigger. You can see that because that box is 0.64, which we found in question, I think part 1 of this question. And as for the IQR before 1980, I'm looking at this value 0.44. All I did was I took 11.53 and subtracted 11.09 from it to get that 0.44 as the interquartile range. Now finally, with any kind of unusual outliers that you might actually see, you could actually point out the value. Now I would probably say that you can actually say, right, like there is one right there, which is probably around the 10.15 maybe. I'd actually say there's an unusual value of 10.15 degrees after 1980. And I think that's a bit unusual because when you look at that middle 50%, it's all between 11 and 11.6 degrees. So it's just one of those things that you could potentially say as well. So grades wise for this question, you're looking at, is it 1, 2, 3? Yep, 1, 2, 3 again. So 1 feature gets you achieved with supporting evidence, 2 gets you a merit, and 3 gets you an excellence. All right, let's go to the next question. All right, so with this question, Dunedin claim. Okay, so the Dunedin community group, they want to claim that the entire New Zealand has not become hotter. Now, I think you can straight away kind of start saying things why this is not valid, right? Not valid. I would say the first reason being is I'm gonna have to write it down. Yeah, so the first thing that you'd kind of mention is that the data was actually from only one city, and you can't actually use that to represent the whole country, right? That just does not make sense. Number 2, I would actually say that the box plot is probably not suitable, especially to analyze change in trend, right? Like right now, if you're looking at changes in temperature, you're probably better off looking at a time series graph rather than a box plot. Yeah, so I would actually say that's the wrong graph to be using to predict something like that. Yeah, the last one's a bit of a weird one. It's like, when you're looking at comparing temperatures, what happened in 1980 that you needed to actually split it for before 1980 and after 1980, which doesn't really make sense. And you can kind of see that in the graph as well, right? Like when you go to the box plot, there's not really much giving there apart from that one kind of random dot out there. If we were to remove this little kind of piece, then your graph almost looks after 1980 and before 1980 looks almost the same. So yeah, I don't understand why they decided to split it before 1980 and after 1980. So that's another thing that you can actually talk about to reject this claim as well. So one of these statements is going to get you an achieved, and two of this is actually going to get you a merit. But you've got to justify any one of these statements. You can't just kind of just go not valid and just be like that. You've got to actually explain why that's happening. All right, next question. Alright guys, so with the next question, what we've got here is, it says show temperatures were well above average. Comment on this claim, blah blah blah. Okay, I mean, you can kind of look at it and say, first off, it is justified, because if you look at the number of, first off, you look at the well above, right? That is February. So we can kind of say February and June are in the dark, kind of like the dark red zone there. So February and June well above average for pretty much most of New Zealand, right? So for most of New Zealand, we might just put that out for most of New Zealand. That's the first one. So I guess we're kind of saying that the statement is justified. So we kind of need to say that first. The statement is justified, and then we're going to kind of give out our reasons why we think it's justified. Now the next one, having a look at it, is the number of where the colors really stand out. Those orange, red kind of stands out, right? Where it's above average. And if you look at above average or just more than average, you've actually got 5 months there, which is, you've got February, you've got June, you've got August, you've got October and November, because those 5 months, they look fairly reddish, right? So you can kind of say that like we're actually more than average. So that's going to be my second point. And then the third point is like, you know, there's only one really kind of stands out when it's actually below, and that is the month of March. So March there, I'm just gonna write this. So with March, you can kind of see this little blue patch there, where you know, it was much cooler than the usual, but the rest of the months you can kind of see they were like similar or warmer. Now, as for the grades for this question, it looks like this is just an achieved question. It just says just one valid reason to get an achieved. I actually was surprised that, but I guess that's all you get. So you've got to actually give one valid reason, but which is really weird, because when I look at the actual question, it says justify using statistical reasons, give at least 2 different supporting statements. But there you go. It is only an achieved. All right. So next part of this, probability. I always enjoy probability. All right, so with this question, what we've got is, what's the probability it'll rain both on Saturday and Sunday? That is probability of rain on Saturday and Sunday. So what we've got to do is we've got to take probability of Saturday rain, multiply with probability of Sunday rain. So always remember, guys, it's like that and generally is multiplication. So here we've actually got probability of Saturday is 0.2, probability of Sunday is 0.1. Remember that 20% is 0.2, and 10% for that Sunday is 0.1. So we're going to get 0.02. Well, you know, or you could have it as 2% or 1 over 50, whichever. Grades wise, this question is worth an achieved. All right, so the next part of the question is, what do we got? We've got, what is the probability that it rains on either Monday or Tuesday or both days? So there's a few scenarios that are actually happening here, right? So first off, you could actually have, let's say, raining. So it rains for Monday, and then it doesn't rain for Tuesday. This is one situation that could happen. Or it no rain on Monday and rain on Tuesday. And then your last situation is it rains on a Monday and it rains on a Tuesday. And so what we're trying to do is work out all those three separate probabilities, and we've actually got to add them up together. So first off, we're going to do probability of rain on Monday and no rain on Tuesday. So if we go back to the table, raining on a Monday is actually 0.7, because that's what it is. Now, no rain on Tuesday is 40%, while no rain on a Monday is 30%. All right, so keep that in mind, and then we're going to kind of work that through now. So for the first probability, we have rain on a Monday, which is 0.7. No rain on a Tuesday is 0.4, which actually gives us 0.28. Next situation, we've got probability of no rain on a Monday and rain on a Tuesday. No rain Monday is 30%, so that's 0.3. Might just put, so that's no rain on a Monday. Sorry, I should have done this before. 0.7 was rain on a Monday, and then 0.4 was no rain on a Tuesday. That's good. What else do I have now? Multiplied by rain on a Tuesday, which happens to be 60%. Well, now that's going to be 0.6. So that's the rain on a Tuesday. So I've got 0.3 times 0.6, which is 0.18. And then I've got probability of rain on a Monday and rain on a Tuesday. So rain on a Monday is the yellow one, which happens to be 0.7. Just want to put these colors in there, otherwise I'll mess it up always. So that's the 0.7 was rain on a Monday, multiplied, because it's and, rain on a Tuesday was the pink color, which is 60%, which is 0.6. And so I'm going to get 0.42. Now, the overall probability is when I add it up all together. So probability for rain on a Monday, rain on a Tuesday, I guess it's or, right? So or rain on a Tuesday or both days. And again, with or, what we're doing is we're pretty much adding the probabilities. So we got 0.28 plus 0.18 plus 0.42, which gives us 0.88. So grades wise, full correct answer is going to get you an excellence grade. 2 probabilities found, or correct answer only. Correct answer only gets you an excellence, so that's without any working. 2 probabilities found, I guess we're talking about one of, so you know how you got to find 3 probabilities. So 1 probability is going to get you an achieved with evidence of calculation, so you've got to show the evidence of calculation, and then 2 probabilities found is going to get you a merit. And of course the final answer of 0.88, which could be written as a percentage or a fraction, gets you an excellence. Alright guys, so that's it for this exam here. Now, as I said to you guys before, this is my first kind of attempt at this paper, you know, so I'm sure I've probably missed something there, or maybe missed an explanation. And if any of the teachers are watching it, please feel free to just go in the comments and just you know, if you have like shortcut ways of doing things or like different ways of writing things, please just feel free to write in the comment section. I'm happy to take the feedback and kind of go on my learning journey of learning statistics and how to actually do the exam papers for that. So yeah, hopefully it's not too bad of a backlash, and can actually do more of this. It's weird because normally at the end of the exam papers I'd say don't leave a exam paper empty or anything like that, but in all honesty, I don't know what advice I'd give to you in this particular one. I'm sure it'll be the same as what I do for algebra. Don't leave anything empty. Make sure you answer as much as possible. And I guess as I do more of these papers, I'll start picking up some patterns, and maybe we can actually I can actually share that with you guys later time. Cool. Good luck for your exams, folks. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.